Okay, here's your test for your last test before AP stuff. Chapter 10 test next Friday. Do we not have class? What's up? Okay. Not this Friday. Next Friday. Let me think of something. Okay, so this is currently what it is. Mark just asked me 10 minutes, 20 minutes for 10 multiple choice seems intense. On the no calculator one, let's make sure I did this right. No calculator one, there are 27 multiple choice on no this is for the AP test, on the AP test. And then on the, this is on the no calculator. On the yes calculator for multiple choice, it is only 18 of them. And this is 55 minutes, and this is 55 minutes. So my whole life, I've always said it averages to about 2.5 minutes per question. Is that about right? That's 110 minutes, and you have 45 questions. So times 2.5 is 90. What does that help? About 112.5. So have I always been right? Okay. But when it averages 2.5 minutes, that's because this averages about 2 minutes and change, and this is a little bit closer to like 3 minutes and change. So you see how the average is about 2.5-ish, but if it's no calculator, it's closer to 2 minutes, okay, per question. So we're going to try that one out for 80 minutes next Friday. Then, for perspective, after that Friday, you have about 2.5 weeks of time with me before the AP test. So all we're doing for those 2.5 weeks are reviewing. And it might be a day of, okay, the next day we're going to review mean value theorem and Rolle's theorem and average values. The next day we might review volumes of revolution. Next day parametric. Next day polar. Next day sequences and series, that sort of thing. Inside of those 2 weeks, you are going to have practice AP tests in class, but also practice AP tests out of class. They're optional, but it'll be something like on a Saturday morning. We're going to take it just like you would an AP one. So it'd be like from 7:30 to noon. Or we might do one like a Tuesday after school if you can't make the Saturday one. Because I want you to take it just like AP would take it, where it's not just, oh, 90 minutes today, 90 minutes tomorrow, that sort of thing. It'll be test, 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 all of it all at once, 3.5, 4 hours. So you get the feel of it. So then when you really take the test, you have the stamina to do it. Okay? So 2 weeks left of kind of big stuff before we start slowing down to review. Okay? Yeah. Yeah. What's up, Mark? We're going to do that after. That stuff's not on AP, but it's on like what CU likes. So we'll keep learning after, but AP doesn't do work, so we're not going to do work up front. Yep. So after the AP final, we still have a couple weeks left, and we'll still learn some new stuff that I like or stuff that CU likes. But I'm getting everything AP out of the way for the test. What's up? Yep, AP test. Yep. Okay, so notes today, 10.3, parametric equations and calculus. So yesterday, all we worked on was writing out a parametric equation and turning it into a rectangular form. Today, we are going to work on learning how to take derivatives with parametric equations. Okay. Tomorrow we'll look at arc length and area of surface revolution. These guys are about integrals of parametrics, where these guys, oops, this is all about the derivative. So today I'm going to teach you how to take the derivative of a parametric equation. Okay? So, if a smooth curve is given by the equation x equals f of t and y equals g of t, then the slope of that guy is, and I'll reveal that in a second. Basically, when you read the word smooth curve C, this means Smooth means you can take derivative everywhere. That's what the smooth means. And then the curve part, the curve, see, that's just kind of telling you that's the story of the truck. It's talking about what's the derivative of the path. So what's the slope of the route that he takes? Okay. So dy dx, that's what we're used to, y prime. Dy dx is dy dt all divided by dx dt. Because again, you're using things in terms of t, so I have to do y in terms of t and x in terms of t. So dy dx is dy dt divided by dx dt. And you just got to make sure dx dt is not 0. The reason that works, when you divide, you agree, when you divide you can flip and multiply. So dy dt divided by dx dt would be the same as dy dt times what? Dt over dx. Do you see how the dt's cancel? And you're left with dy dx. Okay? So parametrically, you can still find the regular derivative y prime by doing dy dt divided by dx dt. Okay? So, let's take a look at one here. Find dy dx for the curve given by this thing. It's like, okay. First off, let's just go right at it with, I'm curious, what is the shape of the curve? I want to kind of show you both ways of it. You can do this rectangularly, or you could do this parametrically. Okay? So the parametric way is going to be very straightforward. You could go parametrically right away and go, okay, dy dx. Do I have y in terms of x yet? No. But parametrically, I just taught you that's dy dt over dx dt, which is, let's see, what's the derivative of y with respect to t? Yep, so that would be negative sine of t. And then here, can I take that derivative with respect to time? Yep, and that's cosine of t. So I just discovered that dy dx is negative tangent of t. Now, stare at that for a second. My derivative, dy dx, is in terms of what? T. It's still in terms of t because what mode am I in right now? Parametric. Since I'm in parametric mode, my derivative is in terms of time. Even though it says dy dx, it's still all about t's. Okay? Then could I plug in any time I want and get what slope is? Okay? Or, the way that you're going to be more comfortable with, but parametric, this was quick and easy. Was this nice? Not too hard. Some of you still are liking rectangular. You're so used to rectangular. So I just want to show you how they relate. What's a good way to make this rectangular, the path? How can I make the path rectangular? So that's my two choices. Should I say t equals inverse sine of x? Or should I try and do sine t squared plus cosine t squared equals 1? What's the better way? Right way. So if I do that, I would have x squared plus y squared equals 1. Do I know what that guy is? Yep. So there's rectangularly, and it's up 1 over 1, boom, 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 boom. And there is the, there's I-25. There's the path. Guys okay with that? Now, from there, could I, if I wanted to, could I find dy dx? So from there, dy dx, is this y equals yet, or do I need to do it implicitly? Implicitly. So implicitly, could I get implicitly 2x plus 2y dy dx equals, what's the derivative of 1? 0. So then I got dy dx equals negative 2x over 2y. So dy dx equals negative x over y. Okay? Now, if you stare at that versus what we have up here, this is the same. Who's x in this problem? Negative sign, or x is sine. So what's negative x? Negative sign. And y was cosine, and there's the cosine on the bottom. So do you guys see how it's the same thing? It's just this one here is written in terms of x's and y's, and this one here is written in terms of t. This one here, could I have resolved it, and could I get y equals and then take the derivative? And if you did that, what would your derivative be in terms of? It would only be in terms of x. Okay? They're all the same story, though. Okay? So parametrically, you might care about the start and end. So let's see if we can kind of do this. Let's say t equals 0. What do I get? Where do I start if t equals 0? 0, 1. So that'd be the start. What would be my next good guy to try? Pi over 2. Let's see. Sine of pi over 2 is 1. So I'm going this way. Okay. This here is t equals 0. This here is t equals pi over 2. Okay. Let's try something out then. If I know that, let's right here do dy dx at time equals 0. What's tangent of 0? 0. Does that make sense? The derivative at time 0 is 0. Is that true? That's a horizontal tangent. Let's do pi over 4. Or sorry, pi over 2. What's dy dx at pi over 2? So tangent of pi over 2, undefined, right? So it'd be like negative undefined. And a lot of times when it's undefined, that's really because it's really negative infinity. It's vertical. Is it vertical right there? Okay. What time do you think is right there? Pi over 4. If this guy, top guy is pi or 0, right guy is pi over 2, I bet that one's pi over 4. Can you tell me visually, what does that slope look like? Negative 1. Do you plug in pi over 4 into this? You're going to get negative 1. Okay? You guys okay with that? Could you also plug it all into here, but there you're plugging in the coordinates x's and y's, and you'd get the same slope. Okay? Okay. Next part is the very important part. Taking consecutive derivatives. Most importantly, the second derivative. Okay? If I want to take second derivative for like concavity checks, this is wrong, even though this is what people are going to think it is. What was the first derivative? What did I do? dy dt over dx dt. So like y prime over x prime. So a lot of people think, okay, so second derivative is probably y double prime over x double prime. No. This is wrong. No, 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 no. Too many people think it's this. Take the first derivative, and then you just kind of do it the same way. Nope. The only reason people miss this problem on any AP thing is because they don't know the formula. They assume you just take 2 derivatives on top and 2 derivatives on bottom. That is wrong. Okay? From what we just learned, I want you to think through how we just learned something. What we just learned was, stare at that, it might look a little bit different notation for a moment, but d dx of dy, is that the same as dy dx? Is the derivative with respect to time of y all over dx dt. I just wrote it a little bit different. And then the third way is the way I just wrote it on the last page. Pattern match. If you guys agree with that statement, then is that saying take the derivative twice? Take the derivative of the derivative. That's saying it twice. Pattern match. So what is that going to be? It's going to, what's going to go on top? D dt of who? No. dy dx. Kind of see how the y goes to here. So this probably needs to go right to there. So it's going to be the derivative with respect to time of the first derivative divided by what? dx dt. Okay? This is the other part that a lot of people forget. So a lot of people do one of two mistakes. They either think you just take the derivative twice of the y and twice of the x and call it good. That's a no. Or they think this. Once you get the first derivative, you just take the second derivative from it, but they forget the divide by yellow part. I'll show you all of those examples here on the next slide, but that's where the mistakes happen. Okay? So you take the derivative with respect to time of the first guy, but you always, every single time you take more than one derivative, what are you always dividing by? Always divide by him. If it's the first derivative, if it's the second derivative, if it's the third derivative, you always divide by him. You take the derivative of your first derivative and then divide by, not the first derivative, dx dt. That's only part of, okay? So let's take a look, okay? For the curve given by this, find the slope and concavity at the point 2, 3. Okay? I already showed you what the parametric version of this is. Does it make sense that it almost feels like it should be like a parabola or something to the fourth? How come you only have half of this? Yeah, because you can't have negatives. Is this similar to, I think, number 8 on the warm-up that we did today, where you only are the positive versions? All right. So if I want slope, I would go dy dx is dy dt all over dx dt, which is, okay, the derivative of y is, this guy's derivative is 1/2 of t. Okay? Bring the 2 down. 2 times 1/4 is a half. Half of t. All divided by 2 square roots of t with a 1 on top there. That's like those mad minutes back in Calc 1. And let's see, to simplify this, simplifying, I get the 2's cancel out, and I get t times square root of t, which is t to the 3/2. You guys okay with that? The 2's cancel, and yep. So dy dx is t to the 3/2. I don't know. Did I do it wrong? Pause. So is it easy from there to say at point 2, 3, I could just say at 2, 3, I could get dy dx equals, okay, yikes, 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 yikes. Can I plug in a 2 or a 3 to this? Does that help me plugging in a 2 or 3? No, who do I need to plug in? T. So at 2, 3, I need to know, what does t equal? So what I would do is go, okay, I can do this. I'm going to focus, let's say, on this guy. X equals square root of t, and I know 2 is my x value. So what does my t have to be? T has to be 4. So I would be plugging in 4. And so then I'd go dy dx is the 4 to the 3/2, which is 8. So at 2, 3, notice that they already said t equals 4. That slope is 8. Okay? You guys okay with that? Now, here is where the big mistakes happen. If I want the second derivative, here comes the 2 mistakes that people are going to do. First mistake would be this. Here's the first no. Okay, d squared y over dx squared. They're going to focus on this. And some people might try and just take the blue derivative one more time and the red derivative one more time. No, 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 no. You cannot just go with, what's the derivative of 1/2 of t? 1/2. And then the derivative of the other guy, that other guy is like t to the negative 1/2 and a 1/2 out front. So then negative 1/4 t to the negative 3/2. You cannot do that. Do you see what I did? I tried to, I'll start. I tried to take the derivative of that guy and I put him right there. And then I took the derivative of that guy and I put him right there. You cannot do it that way. Okay? That's the first no. That no doesn't happen as often as this no. A lot of people say that the second derivative, do I already have the first derivative? So then they go, well, if I already have the first derivative, then it must just be 3/2 t to the 1/2 done. That's wrong. Because every time you take a derivative, what do you always have to divide by? The dx dt. This is half right. This is actually half right. But you need to remember, here comes the yes. The second derivative, d squared y over dx squared, or if you want to do y double prime, that's fine. It's the derivative of the first guy, always, always, always what? The part you just did, this is correct. That part's correct. That's the derivative of that guy. But I still have to divide by dx dt. That dx dt you found way earlier. Who was he? Come up here. dx dt was that guy, the 1 over 2 square roots of t. So I need to put that 1 over 2 square roots of t. That, if I want to take the third derivative, what's the bottom already? That thing. Fourth derivative, that thing. Fifth derivative, that thing. Okay, better. So then that gets me, let's see, 3t. So then if I want at 2, 4, I really care, that means time equals 4. That means my second derivative is really 12. Is okay with that? Okay. What's that? Oh, is that 2, 3, not 2, 4? Sorry. 2, 3, but the time is still 4 for that. Okay. Try this one out. Okay. And we'll take a look at this one. This is just talking about tangent lines. So do I need to take the second derivative here? No. Do I need to take first derivative? So try this one out. With time running out, video people, you should go to the Blackboard and take a look at this page and just kind of reflect on it a little bit. I kind of wrote it as quickly and cleanly as possible so you can kind of follow this last page for understanding. Okay, and the homework is right there.